Hey, it's Mr. Peterson. This screencast is about states of matter and the properties of matter that allow us to have different types of molecular interactions. So we're going to focus on interactions between molecules. Let's start talking about this dead Greek guy, Democritus. Greek fella lived in around 400 BC, so a long time ago. And his idea was that if you took a loaf of bread and you kept slicing it into smaller and smaller pieces, what would you eventually get to? Well, eventually you'd get to a bunch of breadcrumbs, right? Well, yeah, I suppose you would. But eventually you'd get to something that was just the very essence of what we term as an atom. So for him, it was more of a thought experiment than anything. And so we're going to talk about the interactions between atoms here in this screencast. So the business of states of matter. So, right, we've got solids, we add some energy to it. What do we get? We get liquids, and then we add some more energy to it, and eventually we get a gas. So as you're taking some notes on the screencast, I want you to pay attention to a number of things. Number one, energy. So where's the energy in the relationship between these states of matter? What happens when you increase or decrease? What happens to the attractions between molecules? So not in the molecules themselves. So we're not talking about relationships between like bonds between atoms. We'll talk about that in the future, covalent or ionic bonds, but the interactions between molecules here. So think about energy here. So what happens when we increase energy? Okay, so if we had a beaker, you know, kind of like Beaker from Muppet Labs there. Me, 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 me. You know, Muppet Labs, maybe you've never seen the Muppets. In solids, the molecules are moving slowly, right? So they're moving. So we've got this chunk of ice inside that beaker, and the molecules are moving slowly. If we add some energy to it, what happens? We change states. The liquid takes the shape of its container, and the molecules move faster. We continue to add energy, and what happens? Well, the molecules fly everywhere because we change states again. We turn it into a gas. So in those three states of matter, solids, liquids, and gases, and that's our normal experience, right? So in the sun, we have stuff called plasma, which is a superheated gas where we strip electrons from it. But for the most part, you and I don't encounter plasma or even something at the other end of the spectrum, that Bose-Einstein concentrate. We don't see that. Okay, so if we take a solid and we add some energy to it, what happens to that solid? It becomes a liquid. What's that process called? So we got six things we're going to talk about here. We call that melting, right? We go from ice to liquid water. Then we add some more energy to it, a liquid to a gas. What do we call that? We call that vaporization. So when a liquid turns into a gas, that's vaporization. So vaporization is not just water, any type of liquid, gasoline, when it turns into a gas, when it vaporizes, right? So if we go the other way, if we take energy away from a gas to a liquid, what do we call that? We call that condensation. So condensation happens when we go from a liquid to a solid. We take more energy away from that. We remove energy from the system, take away heat, and what do we get? We get freezing. So we've got those four states: melting, vaporization, when we increase energy, condensation, and freezing, when we decrease energy. You can also skip those in-betweens, So, for example, sublimation. So there's that's a dry ice. So frozen carbon dioxide, it can go right from a solid to a gas without being a liquid. And you've probably seen dry ice, or maybe you've even played with it before. We can also, the other direction, like this morning, I had to do this, right? So some water, which was gaseous, it was in the atmosphere. It was cold enough that it froze to my windshield, so I had to scrape the frost off my windshield. That's called deposition. So we go from a gas to a liquid. So we have these 6 things. It's all about what happens to the energy. Those are the different states of matter, solid, liquid, and gas, and that depends on the energy. All right, now if we look at this really quick, so we had some solid, and we had some energy to it. It's going to melt, right? So any solid could be wax that we're heating up. It's going to melt, and eventually it'll turn into a liquid when we add enough energy to it. And you know that you have to keep adding, if we had some ice, and we'll explore this a little bit in lab. If you had some ice, turn it into liquid, we still have to add energy to it before it can jump into a next state. Well, once we have to a liquid and we add some more energy to it, eventually it's going to boil, right? And the gas, once we get to that vaporization temperature, the gas is going to be moving super fast and it's going to change state. The liquid will change state to a gas. All right, so it's about those intermolecular connections. So again, we're adding energy to go from a solid to a gas. What happens when we take energy away? We go the other direction, right? We condense things. We go from a gas to a liquid, that's condensation, and from a liquid to a solid, that's freezing. Nothing new there. Those should not be new ideas to you, right? Okay, so if we look at, here's an interesting relationship. You know, it's been kind of wacky. They've had snow in Florida this winter, and sometimes it gets pretty cold. Why the heck would you spray oranges with water? Think about that. When water goes from a liquid to a solid, what happens? What happens? Think about those phase change, that little diagram we had just a second ago. What happens? What happens when that occurs? So the phase change, we go from a liquid, it loses some energy, right, to become a solid. And where does that energy go? Well, in this case, it goes into the oranges, and it keeps the oranges from freezing, which is kind of wacky. Even though it has this coating of ice around it, the inside of the orange is not frozen. So there was enough heat going from the liquid to a solid. That energy was lost, and the orange absorbs it. That protects the orange. Kind of wacky, but that's what they do. They do it with strawberries. They do it with all kinds of fruit. Okay, we call that an exothermic reaction. It gives off energy. The energy is exiting. Okay, we go the other direction. If we take a liquid and we turn it into a gas, so here's some sweat, right? Perspiration that goes from a liquid to a gas. That's an endothermic reaction that absorbs energy. Where's the energy coming from to turn it into a gas? It's coming from you and I, right? So when those molecules heat up, because we're working hard, we're working out, right? It's going to absorb energy, and it's going to turn into a gas. And what happens to that heat? Well, the gas takes it with it. It has absorbed the heat because it's changed state, and that cools us off. So evaporative cooling is an endothermic process. Okay, if we look at energy, big idea there. What happens to energy going in and out? If we look at the order of the molecules, that's a property called entropy. So here's some water molecules, and they're we've played with these guys before, right? So right now it's a highly ordered system. There's order to it, which means they're all arranged very nicely. The intermolecular bonds are holding them together nicely. Here's sodium and chlorine, highly ordered, regular pattern. What happens when you add energy to that system? Well, when we add energy to solid water, what happens? Well, the molecules become disordered. We go from nice, pretty snowflakes that we've all made before to crazy separate water molecules. Whoa, water going everywhere, turns it into a gas. So the entropy of the molecules, the order of the molecules decreases. We go to disorder. So I hope that makes sense. Ask some questions about that. Okay? So molecular attractions. So if we look at the attractions in molecules, we have really good molecular attractions in solid water. So here I'm making an ice crystal again. Nice molecular attractions. As we increase the energy, we decrease the attractions. Why? What are the molecules doing to decrease the molecular attractions as you add energy to them? What's happening to them, right? What's happening to these molecules? We're adding energy, they're moving faster. If they're moving faster, they're vibrating, they change state. Okay? So the molecular attraction, and it takes some energy to overcome that molecular attraction. Same thing with these sodium and chlorine ions. It takes some energy to pull those apart, right? So the molecular attractions, as we go from a solid to a gas, that molecular attraction decreases. Okay? So as we're thinking about attractions between molecules, as we're thinking about energy between states of matter, keep those things in mind. Energy, attraction, where's the energy going, and those kinds of ideas. So if we're talking about states of matter, pay attention to those things and come back with some questions. Hope that helps.